Okay, so again, tomorrow your test, you'll have a calculator. It'll be all free response. The whole thing will be free response. So it might take a little bit longer for me to grade. I'll try to have them on Friday so we can go over them Friday. That'd be a good thing to do right before Thanksgiving break. But if not, I do have Thanksgiving break to grade them, and then Friday we can just we could do like a Thanksgiving search a word or something, right? Or we could do turkey dances.
We could turn math into a turkey.
We can. No, we could trace our hand, right, and make turkeys like we did back in the day. But that's if I don't have them graded. I may not have them graded. I got a lot to work on, including putting together all the thoughts that you're sending. Just shoot me an email, okay? Good. I'd love that. All right. So whenever you reset your calculator, unfortunately, you got to retype in the equation. So that's the first thing I want to do. We're still working with this polynomial. So 2x caret 3, click to the right, minus 3x squared minus 3x plus 2. Okay, so I got it in y1. Again, here's something else you could do. We didn't really do this yesterday because we were working with one equation at a time. But sometimes you might have more than one equation. In calculus, sometimes we have up to 3 equations at a time. We have our position, velocity, and acceleration equation. So if you put it in y sub 1, even though it's called f of x, it's not a bad idea to come over here and call it, I just call it y1 instead of the subscript. You know, you could put y sub 1, but you know, you can call it y1 or y2. That works as well. So I'm going to call it y1 as well. All right, so we're down here now. Find the local max or min. So if we hit zoom 6, remember zoom 6 is our standard window, and this graph fit nicely in this window. We have one local max and one local min. Okay, those are essentially the vertices. Now, it's important to call those local maxes because they're not maxes. If you just say maximum value, that implies global maximum or absolute maximum. And if you think about this function, there is no global maximum because it increases without bound. It goes up forever to infinity. And there is no global minimum. But locally, if you zoom in on a small, relatively small local interval, that is the high point in that interval. Okay, so that's why we have to call them local maximums. Now, the local maximum itself is the y value, and they occur at x values. So we're going to go ahead and write out the terminology first, because this is what I want you to write. F has a local max, you can abbreviate it max, and we're going to say of y equals blank at x equals blank. So instead of writing it as an ordered pair, I don't know how you did in algebra 2, we're going to separate it, okay? And that's to help us or help remind ourselves that the maximum value is the y value, and it occurs at the x coordinate. Now, in calculus, we find these without a calculator, but this is pre-calculus, so we're going to let the calculator do the work. So how do we do that? Well, from the graphing screen, let me write that. From the graphing screen, we do second trace. Second trace is kind of like your best friend window from your graphing screen. It's your calculate window, and you got all these different options. Guess which one we want if we want to find the local maximum? Yeah, it says maximum, but it's the local maximum. So we're going to select 4, right? And it's going to ask you for 3 pieces of information: left bound, right bound, and guess. So for your left bound, all you got to do is scroll until you know for sure you're to the left of that high point. Okay, and it's nice you have a visual here. Yes, I can clearly see that I'm to the left of the maximum. So how far to the left do you want to be? Not too far. How close to the high point do you have to be? Not too close. You know, if you want to come down here, that's fine. I know I'm definitely to the left. I'm going to hit enter, and notice that locks in this x coordinate, puts a little arrow at the top. Now, for your right bound, you have to click to the right. I'm going up, I hit the high point, and I can clearly see now that I'm on the way back down. Make sure you're clearly on the way back down. Somewhere, hit enter, and now you've blocked in this point. So somewhere in that little interval, you're claiming there's a high point. For your guess, don't even move the right endpoint. When you hit enter for the right endpoint, don't move it, because for your guess, you can just hit enter. You don't have to do anything with the guess. It could be the right endpoint. And what it does is it numerically scans that interval and it looks for the highest Y value. All right, so there it is. It's listed down below. Now you do have to be careful when you list them, because notice it lists the X coordinate first and the Y coordinate second. But when you write it down, I want you to write the Y value first. The Y value is of, okay? And we go to 3 decimals, right? 2.598. Not 2. You're going to get it wrong. If you report 2 decimals on the test tomorrow, anybody, not just Brady, it's going to be wrong. Okay? 3 decimals, round or truncate. Okay? Why'd you do 2, Brady? Just out of habit, or? Yeah. Well, in this class, we want to develop a new habit, 3 decimals. I know in science class, maybe sometimes you do significant figures or digits, whatever you call them. But in this class, we don't do that. We just do 3 decimals, round or truncate. So it has a Y value of that at X equals negative. I like to put the leading 0. You don't have to. 0.366. Okay. Now, because at is technically an adverbial clause, am I going to take off if you put the at part first? No. Okay. But what's important is the of attaches to the Y and the at attaches to the X. Okay. That's important. There is a local max at X equals blank of Y equals blank. That's fine. But I prefer it this way. Of is the Y, at is the X. Okay. So go ahead and find the minimum now on your own. You're going to do second trace number, but look, second trace number, guess which one? 3. Okay, go ahead and find it. I'll find it. I don't know what it is, Brady, but I'll find it with y'all. And then use a complete sentence. Okay. I'll just do it up here with the recorder running, and we'll get the same answer, hopefully. Do your math homework from 4.1, but it's not due tomorrow, right? Yeah, good. And you can abbreviate maximum and minimum as max min. That's fine. All year long, you could do that. All right, so here's what you should have. Second trace number 3 from the graphing screen. F has a local minimum or min or relative min. I'm just going to throw that word out there. We call local minimums also relative minimums. Okay, either one, but you do have to have an adjective in front of it, either local or relative. It's Y equals negative 2.598 at X equals 1.366. Y'all got those? Okay. Just a real quick word. We have local max and mins, and we have global max and mins. Okay. Now we haven't really talked about global. If you're talking about local max and mins, those are your hills and valleys. You can have multiple of them. But if you're talking about global max and mins, think about like the globe, right? There can only be one global maximum, if any. I put global in parentheses here because you don't even have to say it. If you just say max min, everyone's blessed, you're going to assume global, but you can certainly say global. So those words tie in together, right? Mr. Wenzel would be proud. Geographic terms, locally, thinking ethnocentrically, globally. Okay. So there would be no global max or min, as we already said, because these go to infinity and negative infinity, but we still have local max and mins. Or there's a whole nother set of nomenclature. You can call them relative max and mins. And then the counterpart to that would be absolute max and mins. We'll study those a lot more if you go on to take calculus, okay? But local means relative, because if you think local, you're zooming in on a local municipality, on a local interval. Same thing, relative. You're zooming in on a relatively small interval versus the absolute maximum, which is over the entire thing. So those are the terms that usually get paired up. If you use local, then you tend to use global. If you use relative, you tend to use absolute. On your test tomorrow on the calculator, you're only going to be asked to find the local maximum. Okay. Now, for what it's worth, one more term. I think I used it yesterday. Max and min collectively combine to be called extrema. That's the math term. And extrema means extreme y values. That's what it means. So it is a plural term. Instead of saying extreme y values, we say extrema, right? So there are a few words that when they're pluralized don't end in s, right? Like extrema is plural, but it doesn't end in s. What do you call two ox? Oxes? No. What do you call two box? Boxes. But when you call two ox? Oxen, right? Oxen. Yeah. I'm trying to get a group of unicorns. A group of unicorns is called a blessing, I think. I think that's what someone came up with. I'm not sure.
I mean, a group of crows is called a murder.
A group of crows is called a murder of crows. But I would like to kind of borrow what is the pride, right? The pride of, is it tigers or lions? Lions, the pride of lions. Now that's not going to be good if they become the Long Creek Lions, because then they're going to call themselves the pride of lions. I would like a group of unicorns to be called, like a group of lions, a pride. Unicorn pride is justified. So let's see if we can get that out there. What do you call a group of unicorns? A pride. A pride. Yeah, a pride of unicorns. Yeah. All right. Good morning. Okay. 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 Now look at this one here. This one, part F, it says find of f of 3.5 minus f of negative 2.5. Okay, no big deal. We could do that. We're going to go ahead and write it down. Even though it says there, we're going to say f of 3.5 minus f of negative 2.5. And I'm going to go left to right. I'm going to put equals. Now, if we do this from the graphing screen, we're going to have to find f of 3.5 and f of negative 2.5 separately. And then we're going to have to store them. You want to see what that looks like? Might as well. Options. Options. Okay. So we'll call this method A. This is the method that I would not encourage you to do. Don't do it this way. But I'll show you. If you hit trace and you type in 3.5, it gives you the y value of 40.5. Now 40.5 terminates, right? It terminates. So you could just write down 40.5 if you want. But what if that number had so many decimals it didn't terminate? Here's what you could do. If you go to your home screen, second quit, notice if you hit X enter, I'm sorry, not X. Where did it show up at? It was the Y value, right? Notice X is 3.5. That's the number I just typed in on the home screen, on the graph screen. Alpha 1. If you hit alpha 1, that's your Y value. Hit enter. There it is, 40.5. Anytime you go to the graphing screen and you type in an X and get out a Y, it automatically stores them in X and Y. So you can access those from your home screen. Okay. But if I were to go back now on the graph screen and type in -2.5, it would overwrite X and Y. So one option is if this number 40.5 had a bunch of ugly decimals, you could store it as something else before you found the other one. So let's do that. Let's do alpha 1, store it as alpha A. Okay. Now, if you hit alpha A, it's in there. Notice what I did. I did alpha Y, because that's where it stored it. And then I did store as, and then I picked another letter, alpha A. Yeah. Store is right above on the bottom left. It says stow arrow. Now, if you want to do this, alpha 1, enter. If you want to see the number first, just to verify it, alpha Y, enter is 40.5. Now you could just hit stow as alpha A, and it'll take the answer from the previous line. Either way. Okay. Uh-oh. Okay. So let's go back. Go back to trace. Type in trace and do 3.5, enter. Do you see 40.5 on the bottom? Okay, now let's try it again. Go to the home screen, second mode, and now hit alpha 1, stow alpha A. Hopefully it shows up now as 4.5. Second mode, yeah. Scroll back and hit alpha A. Enter. There it is. Okay. Good. So what I would do now is I would, underneath here, I would just write A. Okay, if you write it underneath f of 3.5, that's a reminder that you stored it as A. Now go back to the home screen, graph, hit trace, and now let's type in -2.5. Notice it gives you -40.5. Okay, well, let's go to the home screen. Now if I hit alpha 1 and enter, notice it's now the other number. I'm going to store that, stow, as alpha B. And now I'm going to put -B. This is another way so that you don't get messed up with all your minus signs, because now we're subtracting a negative. So I found this, went to the home screen, alpha 1 stored it as A, found this on the graphing screen, went to the home screen, alpha 1 stored as B. And I'm showing what I'm storing them as. Now I can go back to my home screen, or I'm there, and I can just hit alpha A minus alpha B. Boom. And you get 81. So that's how you store values from the home screen. Now, did you have to do it like that on this problem? No, because they were terminating decimals. 40.5 minus -40.5 is 40.5 plus 40.5. But if they end up being funky decimals, you don't even have to write down the 3 decimals there if you store it as A, okay? Now, I wouldn't do it that way. Here's how I would do it. I put the equal sign and I work down, so I'm going to erase it. What I would do is just say f of 3.5. That fine shouldn't be there. Sorry. We need to fix that. F of 3.5 minus f of -2.5. Okay. I would just do it straight from the home screen, right? My equation's in Y1. So alpha trace, enter, of 3.5, close parentheses, minus alpha trace, enter, parentheses, -2.5. Okay, double check, triple check, that looks good. And there you go. Now you can just write down 81. You don't have to do any of that intermediate stuff. That's how I would do it. That's the power of the calculator. If you just put 81, no credit. But when you write this up above, even though it was given to you, kind of, right? There was an extra word in there. Even though it was given to you, when you write this down, you're telling me that that's the relevant part of the instructions. That's what you're evaluating. That's what you're typing into your calculator. You're using your calculator as a tool in a good way, right? Not like when you call somebody a tool, right? Yeah. What a tool. Okay. All right. Kind of the same thing here. Find if f of pi is equal to a, find 3a minus 5a. Okay, well, I could do kind of what I did up here. I could do 3 And then I can do y1 of pi minus 5 times y1 of pi. I could do that. I could type it into the home screen just like that and never have to store anything, right? That's fine. Or I can do this. I could say alpha trace enter of pi, and then I can hit enter. Now notice it's a funky number, okay? So what I might do is say f of pi equals 24.978. And I like to put dot, dot, dot. You don't have to do that. But when I put dot, 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 that's a reminder to myself that there are more decimals there. And anytime I'm going to use that, I need to use the live number. That is the number in its full decimal glory. I'm going to store that as A on my calculator. So then I'm going to write that equals A. So now I'm just going to hit store as alpha A. Boom. And now it's in there as A. So if you did it that way, then all you have to do is you would show me that, right? You would put this over here. And then you would say, once you have it as A, then you would just say 3A minus 5A. And then you can just type it in, 3 alpha A minus 5 alpha A. And you get negative 49.957 or 958. I don't care which way you do it. But when do you use a rounded or truncated number for a subsequent calculation? If you can help it. Never. Never. Okay? Never. If you have something that has funky decimals and you're going to be using it later on, store it. You have all the letters on the alphabet except X and Y. Store it. And whatever you store it as on your calculator, show that on your paper. Then, as an intermediate answer, not a final answer, you can show me how you're using it as that stored letter, because I know exactly what it is. And that's another reminder to yourself to, when you type it in, to use that. That's the power of the calculator. Okay. All right. The last thing that we're going to do here is to show how to use the calculator to solve. So up to now, it's been easy relatively. I've been giving you an input and you've been finding an output. When I give you an input, you could just go trace, type in your input value of X, enter. You can go to the home screen, Y1 of the input, enter, boom. But your calculator can also be used to find inputs when you're given an output. You can find X values when you're given a Y value, but you have to do it graphically, okay? So on part H, it says find the roots. Hint, that's when f of X equals 0. All right, so real quickly here, let's go ahead and write what roots are. Roots are the same thing as zeros, which are the same thing as X-intercepts, which are the same things to solutions to the equation f of X equals 0. They all mean the same thing. Every single one of these means the same thing. And the reason is, I guess, because of this. If you think of like a graph, something like this, these would be the roots right here. We would call that maybe X of 1, X of 2, X of 3. And the reason maybe they're called roots is because if you think of the X-axis as being the ground, right? The roots kind of grow underground. Now I know then that that's not really the same as a root for what we're calling it, because ours is on the X-axis, but it's the divider between the ground and the airspace above, right? So you got roots growing underground, and then you have like the flower growing up above, right? Whatever, flower grows up above. So the roots are going to be right there where the X-axis is, okay? So that's why they were called roots back in the day. Now, they're also called zeros. A lot of people don't call them roots anymore because it's kind of an old boomer term, you know? I still call them roots. but they're also called zeros. And that's a good word too, because that's where the y value is 0, right? That's literally where the y value is 0. And that's exactly why they are solutions to the equation f of x equals 0. Because what's another name for f of x? Y. Yeah. Now, why are they called X-intercepts? Well, what does it mean to intercept? It means the unicorns step in front of the Westlake offensive pass and catch it and run it back for a touchdown on their way to a victory, right? That's what it means to intercept. It means to cross paths or to step in front of. So that makes sense. This is also where the graph of f crosses the x-axis. So they all mean the same thing. So if I ask you to find the roots, you don't know what the x value is, but you do know what the y value is, right? It's 0. So you're going to have to show me the equation that you solve. So let's do that. We're just going to show f of x equals 0. That's all you have to show for the calculator portion. I'll give you full credit just for showing f of x equals 0. Probably not going to give you the hint. Remember, this worksheet was done for the academic. I'm not going to give you the hint. So you set it equal to 0. Now, there's two things you could do. Watch this. Your calculator, if you go to the graph, how many zeros do we have? How many x-intercepts does this graph have? 3. Let's go ahead and find the one on the far left. Back in the day, your teacher might have told you to find roots by going to the table. I see people scanning through the table all the time. If you go to the table, you might stumble across it. Go to your Y column and look to see where 0 is. Hey, I found a 0. Well, back in the day, that might have worked because back in the day, your equations were all nice and simple, and your x-intercepts were nice positive integers. And your table was set up to count by nice positive integers, so they would show up in the table. But guess what? They're not going to show up in the table tomorrow because your x-intercepts are going to be ugly numbers that probably have more than 3 decimals. So they're not going to show up in the table. So
second trace 2, that gives you.
Very good. Let's talk about 2 ways to do it. If you go to your graphing screen and hit second trace, here's the way I don't want you to do it, okay? Second trace number 2. Notice it says 0. I'm not going to prevent you from doing it this way, but I don't care. This is not the way I would do it. But let's go ahead and choose 2. It's going to ask you for 3 things, just like it did for the local max min. It's going to ask you for a left bound, a right bound, and a guess. If we're trying to find this leftmost x-intercept, a left bound is going to be below the x-axis in this case, and a right bound is going to be above. Okay. Notice if you're trying to find the second x-intercept, though, the left bound would be above and the right bound would be below. You're basically trying to block off a piece of the graph where it crosses. Okay. So let's find the one on the far left. We're going to scroll, and if you can't see where you're at, look, I'm already at -4, -560. So I'm flying by instrumentation. I need to click to the right. So I'm coming back up from negative land and my cursor should appear. There it is. So now I can clearly see I'm to the left, right? I'm going to hit enter. And now for your right bound, you click until you know you've crossed. Okay. I can clearly see I've crossed the x-axis, so I'm going to hit enter. And then for you guess, you hit enter. All right. So you can write them like this. You can write your x-intercepts as x equals -1. Or if you want to write it as an ordered pair, -1, 0. We're not going to be sketching a graph of this. So I don't care how you write it. If we were to be sketching a graph of this, I would have you write them as an ordered pair because it's something you can plot. But if you just put f of x equals 0 and x equals -1, that's good. Now that method totally works, right? As you can see. But here's how I would recommend you do it, okay? Or in Y2, graph 0. Go back to y equals, and in Y2, graph 0. And hit graph. Now, if you have a color calculator, you're going to see a nice red line come across the x-axis. Mine is black and white, so I don't see anything. But I physically graphed the x-axis, y equals 0. Now, why would I want to do that? Well, because your calculator can find points of intersection between 2 equations or 2 graphs faster than it can find roots or zeros of one graph. Now let's do this. After you graph y2 and 0, go back to second trace. But now guess what we're going to use? Second trace number 5, intersect. Yeah, second trace number 5. Now look how much easier it is. Let's find the same one. It's going to say, is this your first curve? It's going to put you on one of the curves. You can see the equation in the top. It doesn't matter which curve you call the first curve. If you want to call the other curve the first curve, just toggle up or down. I like leaving the curve as the first one. Just let it assign. So first curve, just say, sure, boss, and hit enter. It'll automatically put you on the second curve. Notice it's y equals 0. Is this your second curve, boss? Just say, yep, hit enter. Now, normally, if there's only one point of intersection, you could hit enter for your guess. But in this case, we have 3 points of intersection. So all we need to do is carefully scroll closer to the one that we want. All right, so I'm going to do that. I'm going to scroll over here to the left just to find that one again. There I am. I'm close to it, and I'm going to hit enter. And there it tells you the x value is -1. That's a lot faster, right? Watch, I'll show you how much faster it is. Okay, so here's what I'm going to do. If I'm doing this on my test, here's what I have to write. I'm going to put f of x equals 0, and then underneath there, I'm going to put x equals -1, comma, and now I'm going to do it again. Watch, second trace number 5, enter, enter, scroll to the middle, and then hit enter. And I get 0.5, comma, and then one more. Ready? Here we go again. Second trace number 5. Find the enter button and close your eyes. Watch. Enter, enter, right? And now we just scroll closer to the third one and we hit enter, and it's 2. There you go. Enter, enter, scroll. It's a lot better than scroll, enter, right? It's faster. And if there was only one point of intersection on the screen, then you could just hit enter, enter, enter. Boy, that's nice. Enter, enter, enter. Second trace number 5, enter, enter, enter. Come on in. Enter, enter, enter. How inviting is that? It's easy. So I don't care how you do it as long as you do it. Now, again, tomorrow on your test, you're going to have funky decimals that are more than 3 decimals. So at this point, you can round or truncate. Okay? You can round or truncate. Now, what if I had you do something with one of those X-intercepts? Like, what if I wanted you to do something with this too, but pretend it was like 2 point blah, 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 blah. Well, watch this. If you go to the home screen, second quit, hit X, enter. There it is. There's your 2 point blah, blah, blah. Let's store it as alpha. I'll store it as C. So now I'm going to put X equals 2. I'm storing it as C. And now what if I ask you, what is C squared minus 2C plus pi? Well, you just go alpha C squared minus 2 alpha C plus pi, which is second caret. And there you go, 3.14. Ooh, man. It's almost pi, right? It is pi because, right, I know, because 2 squared minus 2, yeah, 4 minus 4, yeah. But it won't be like that tomorrow, yeah. You'll have ugly decimals. So storing values, any questions on how to store a value? Okay, last thing I'm going to do here. What if I say g of x is equal to 4x plus 7? Find where f of x equals g of x. Okay, well, these two graphs might intersect off your standard viewing screen. So here's what I'm going to do. Watch. If you're solving something, it's always a good idea to get everything on one side and set it equal to 0. Okay. Now, let's put this in like y3. Let's put this in like y4, and we'll find the x-intercepts. Okay. The reason you want to do it like this is because f of x and g of x, they might intersect way up off your screen, like at y equals 72 or something. And we don't want to have to look for it. But if I bring everything on one side, set it equal to 0, I know where the x-axis is, right? It's smack dab in the middle of the screen. So let me show you how you could do this. Watch. This is honors, okay? So I'm going to go to y equals. I don't want to mess with my equation in y1. So again, I have this in y1. I'm going to put this in y2, and I'm going to label that on my calculator or on my paper. y1 equals y2. So in y2, I'm going to put 4x plus 7. Okay. Now watch this. If I go to y1 on the equal sign and hit enter, and I go to y2 on the equal sign and hit enter, I unhighlight them. The reason I'm going to unhighlight them is I don't want to graph them. I want to graph y1 minus y2. Okay. So just like we recalled it from the home screen, look what we could do in y3. I'm going to go alpha trace number 1 minus alpha trace number 2. It's going to take the equation that's in y1, subtract the equation in y2, and now it's highlighted. And now in y4, I'm going to put 0. Now I'm going to hit graph. I'm still in the negative 10 to 10. All right, so I set it up on my paper, f of x minus g of x, and now I get x equals, let's find it. Ready? Second trace number 5. I only have 2 curves graphed. See that? I only have 1 point of intersection. See that? See that? So watch. Second trace number 5, find the enter button, close your eyes. Enter, enter, enter. Oh yeah. 2.964. Boom. And I can still refer to y1 from the home screen if I wanted to calculate it. Okay, that's why it's so nice. Yes, sir. Or truncate, or round, or truncate. Yeah, you're welcome. If you say so, I don't even know. I've forgotten how to round because it doesn't matter. All right. As long as it's how many decimal places, Brady.
If it's 5 or over, you just added 1.
Oh, that's how you round. But how many decimal places do we report? You did 2 earlier. We did 3 now. Okay, good. All right, y'all be ready for your test tomorrow, right? There's not a practice test online that's like that. It'll be like this. I did put another practice thing in Canvas. It's called Calculator 101 Part 2. It's not for a grade. It's just extra practice if you want it. Yeah. You can turn this one in if you want. Okay. Calculator 101 Part 2 is in Canvas. It's an optional assignment. I'll try and work a key to that to get it posted so you can check your work. Okay. Test tomorrow. Fun, 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 fun. It's so fun. Yeah, it is. Oh, to delete everything, go to second plus 7 and then click over to ALL on the